Good afternoon. Am I audible clearly? All of you can listen? Yes. Okay. Okay. Fine. I hope I am visible there on your screen as well. Okay, that's good. In the last lecture, we have finished with the first part of unit number 1, and we actually started with the second part. So that was nothing but the economics of the power generation. Okay, the second part of the unit number 1 is titled as economics of the power generation. So this particular topic for the economics of the power generation, so that essentially is related with the calculations of the cost of the energy for the particular type of the power plant. And we have seen which costs should be taken into consideration as far as the fixed cost and the variable costs are being concerned. Okay, fixed cost and variable cost or the operating cost, these are the costs which can be classified at the very broad level. And then under the fixed cost, you are having the different types of the costs. Similarly, for the operating or the variable cost, different types of the costs are also incurred. We will quickly recap through what the points that what we discussed in the last lecture. And as far as the today's lecture is concerned, so the topic which is for the discussion today is the selection of the type of a generation. Okay, which points, which parameters should be taken into consideration if you want to select a particular generation scheme or say the particular generation power plant. So what parameters, what factors that should be taken into consideration, that we will discuss. And one more important point or the parameter under the discussion is that the fluctuating loads on the power plant. Okay. As far as these fluctuating loads in the power plants are concerned, our focus for the today's session will be different terms, or we can say the terminology which is used in the these fluctuating loads. These terms, these terminologies are very helpful for us to find out the various factors as far as the economics of the power plant is concerned or economics of the power generation is concerned. So definitely you keep your notebook and your pen ready with you as well, because we are going to write down a few definitions for say some of the terms which are related to the fluctuating loads on the power plant. Okay, so if you do not have your notebook pen, so please make a arrangement for this notebook and pen, and we can write down that one properly. And once we will say finish with the terminology for the this fluctuating loads on the power plant, then it would be appropriate for us to start with the numericals as far as the economics of the power generation is concerned. So that is one part. And the second part is nothing but the different tariff methods which are used for the calculation of the electrical energy, calculation of the cost of the electrical energy rather. Okay, so different tariff methods that we will be discussing in the coming sessions. And toward the end of the unit number 1, our focus would be there for the very important characteristics or the operating characteristics for the power plant. So these are nothing but the contents as far as the second part of unit number 1 is concerned, that is the economics of the power generation. Okay. So let us start with the today's session. I will share my screen there. Okay, I hope that the screen is now visible to all of you. Now we'll just recap the things that we had in the previous session for the economics of the power generation. Okay, we came across the fact that as a being say the student of the engineering thermodynamics, and whenever we are proposing any cycle, so our objective would always be there to maximize the efficiency of that cycle or of that plant, which can be theoretically obtained. So theoretically obtained, it means that the maximum possible value of the efficiency, that would be 100%. But we know that in actual practice, it is never possible for us to get the 100% efficiency. And as the focus is there on the maximizing efficiency, so we are definitely concentrating them onto the different equipments or the different auxiliaries which are used for the operation of that cycle or of that power plant. And one cannot say just in the very tentative manner that the most efficient plant is nothing but the one which is the most economical one. So hardly it happens that the most economical plant is the most efficient one, isn't it? So appropriate balance is required between the various costs, where you can have the minimum cost of the power generation. So that is what the last line which is mentioned in this slide. In majority of the cases, most thermally efficient plant is not the economical one. Why the economy is important? Because we have seen that these companies or the, what you can say, the infrastructure which is required there for the building of the power plant, so that needs a huge investment, and generating electricity and selling that electricity to the consumers is nothing but the business. And when you are dealing with the business, so obviously the profit is nothing but the main concern. Is that fine? So you have to make a proper trade-off between the thermally efficient plant, most thermally efficient plant, and the most economical one. So a proper trade-off or proper balance is required between these two parameters, two terms. We came across the different types of the costs which are required for the generation of the electricity. Fixed cost, and on the other side it is the operating or the running cost. Under the category of the fixed cost, we discussed various costs: cost of the land and building, equipments, the interest which is to be earned from the investment that you have made, the depreciation, which is nothing but the reduction in the value of the asset as it say ages or as it becomes old. So that is the depreciation. Cost of the insurance, definitely some costly equipments are there, so which need to be protected against any undesirable activities like that of say the theft, or it may be the fire, or it may be other undesirable hazard as well. Cost of the management, that is nothing but the salary or the wages, the incentives which are required to be paid for the different personals working for the successful operation of the power plant. So all these costs are nothing but the fixed cost. And operating or the running cost, so very few are there. So cost of the fuel, which is nothing but the input required for the operation of the power plant, and different types of the consumables which are used for the efficient operation of the plant. That is oil, grease, and the water which will be required for the cooling of various utilities used in the power plant, like that of say the compressor, or say that of the cooling tower, or say the condenser, that is nothing but the utility. So you definitely need some water for the cooling arrangements. Okay. So these are say some of the operating running costs. You can add the cost of the maintenance as well. Cost of the maintenance, cost of the spare parts which need to be replaced some or other time. So that is also nothing but the operating cost or the running cost. Okay. So we have discussed this one, the fixed cost, the cost of the land and building. So that is normally expressed in kilowatt of the installed capacity. The interest that we have seen, the suitable rate of the interest must be taken into consideration on the capital invested, because your financer or the investor will definitely be looking upon what return that he can get on the capital that he or she have invested. So definitely rate of interest should be taken into consideration positively. Depreciation, so we have seen that some amount must be kept aside every year, because due to the wear and tear the performance of that equipment will go down as it becomes older. So once the life of that equipment or that plant is over, so that plant or equipment need to be replaced with the newer one. So you have to keep some amount aside so that you can replace at the suitable time. So that is the cost of the depreciation. The different methods are used to calculate the cost of the depreciation: straight line method, sinking fund method, and the diminishing value method. Okay, we will be looking after the formulas for these different methods of the depreciation or for the calculation of the amount of depreciation when we start with the numericals on the calculation of cost of electrical energy. Insurance. So even though we say that the annual premium for the insurance is 2 to 3%, this number looks to be very small, but the actual cost or the absolute cost is very high, because the cost of the equipment may be in, say, the hundreds of the crores, isn't it? So 2 to 3% is very large number, isn't it? 2 crore, 3 crores, or like that one. Cost of the management that we have seen, okay, the salaries which are to be paid for the people who are working in the successful operation of the plant. The operating cost, so the cost of the fuel, so that is definitely directly proportional to the amount of energy generated. If you generate the larger amount of energy, it means that if more output is required, so definitely more input must also be given. It means that the more fuel must be supplied to get the more output. So these are be directly proportional. Cost of fuel and the cost of energy generated are directly proportional to each other. Then cost of the consumables that we have seen. Okay. And the last two lines being the very important for us. So here the total cost of the energy produced is the sum of the fixed charges and the operating charges. So fixed cost and the operating cost. And a very generalized way by which the equation for the total cost of the generation can be given as the last equation, which can be seen in red color: C equal to X rupees per kilowatt. So that is nothing but the fixed cost, the cost of installation. Okay, cost of installation is given as per kilowatt of the installed capacity, and second part is nothing but the Y, rupees per kilowatt hour. So how many number of the units are generated? So that is nothing but the operating cost of the power plant. So first part is nothing but the fixed cost of the power plant. Second cost is nothing but the operating or the variable or the running cost of the power plant. So these were the points that we have discussed in the earlier session. Now let us take the discussion to the next level. Okay. As I have mentioned at the beginning of this lecture, 2 points that we are going to discuss in the today's lecture. One is nothing but the selection of the type of a generation. Okay, which type of the power plant you should select for the power generation, and what factors you should take into consideration for the appropriate selection, isn't it? So that is the first point. And the second point for the today's discussion is nothing but the fluctuating load on the power plants. We are going to see why the load on the power plant normally fluctuates, what are the reasons for that one, and some elementary terminology, some basic terms and their definitions which can be made use of in the fluctuating load of the power plants. So these are the two major topics, two major points for the today's discussion. So let us start with the selection of the type of the generation. So 4 important points are mentioned on this slide. The objective of the electricity generation investment must be optimum or the most efficient use of the national resources, because whatever the input that we are say giving for the generation of electricity, so it may be possible that some of the resources may be available with you only, isn't it? Like that of if you are working there with the thermal power plant, which is coal based, so we can definitely say that abundant amount of the coal is available as far as our country is concerned. So coal is nothing but our national resource, isn't it? So we need to pay some cost for the excavation of that fuel. Then it need to be transported. It need to be cleaned so that it can be made use of at the appropriate level, isn't it? So some cost is required for that one as well. And if some other type of the fuel is taken into consideration, like that of the diesel electric power plant, so our country is not that much is rich enough as far as these petroleum products are concerned or the gas is concerned, isn't it? Uh, this gas as well as say the petroleum products need to be imported from the other countries, and you need to pay a very heavy amount of that, isn't it? So you should make an say appropriate or the optimum or the efficient use of the national resources which are available with you, so which will reduce the burden on your economy and will help us to keep the cost of the electricity generation at the minimum level. Okay, so that is what the meaning or the interpretation of the point number one. Now, once the total energy generated per year, it means that number of units, number of billion units which are supposed to be generated per year to satisfy the needs of different consumers. Okay, and the peak demand are met. Peak demand is nothing but the maximum demand, the maximum load which is likely to be taken by a particular consumer. So once these two parameters are determined, it means that what is the maximum demand throughout the year. That is one point. So which will help us to decide about the install capacity of the power plant. Okay, peak demand or the maximum demand is known. And second, is nothing but the how much amount of the energy must be generated. It means that for how much duration in a year you need to operate your plant, you need to run your plant, isn't it? So that way this 2 points can be correlated. The total energy generated, which depends upon how much number of hours or the duration in a year you run your plant. Okay. So once this total energy needed per year and the peak demand are known, the next problem or the next criteria is nothing but to select an appropriate method for the generation of an electricity. You need to make a proper choice that which type of the power plant would be suitable for me at this location, so that I can satisfy the maximum load or the peak demand of that region, and I can also meet the requirement of the total energy for the consumers within that area. So that is nothing but the point two. So which are the options which are available for me so that I can make a suitable choice? So as far as the conventional power plants are concerned, so choice is very limited for me. Either I will go with the thermal power plant, hydropower plant, nuclear power plant, diesel power plant, or gas turbine power plant. Isn't it? So I need to make a choice out of these five different types of the power plants. So while selecting a thermal power plant, I need to look into some different parameters, different factors. Yes, if these factors are there, then it is appropriate for me to go with the thermal power plant. If not, then I should look for some other alternatives. Okay, so meaning of this line is nothing but that I should take into the various parameters under the consideration, factors under the consideration before I finalize the type of the generation. Okay, and one of the parameter would be say the elimination of some of the alternatives would be done, would be adjudged on the basis of controlling factors such as the water and fuel. Suppose I want to install a hydroelectric plant at a particular site. So I need to ensure that whether that particular region receives an abundant rainfall, whether the site is in such a way that a large reservoir can be constructed. Suppose I am going there with the say the gas turbine power plant. So I need to ensure that whether the source from which I am going to get the this gas, is it available me on the regular basis? Is the reliability in the transportation of this gas from the place of source to the place of the consumption? As the water is also one of the factor. So water will be very important as far as the thermal and the nuclear power plants are concerned, because in both the types of the power plants you need to generate the steam initially in the thermal as well as the nuclear power plant, and for the generation of the steam you need the abundant quantity of the water. That is one point. Second point is nothing but the cooling of some of the elimination type. So if the water is not available, so I will not go with the thermal and the say the hydro and the nuclear power plant. I will say go with the small diesel power plant. I will go with the gas turbine power plant. So likewise, I will make the elimination of the various points which will help me to finalize the type of generation available from these 5 different alternatives. Okay. So this is nothing but a very general picture for the selection of the type of generation. Now, more important points that should be taken into consideration irrespective of any type of generation, isn't it? So I would like to insist to all of you, you please note down these points in your notebook. Okay, please note down these points which should be taken into consideration for the type of electricity generation. So first note down these 6-7 points and then we can discuss these points one by one. Okay, you should keep your notebook and pen ready in all the lectures. So just now we have seen the type of the fuel available or the availability of the suitable site for water power generation. I should take into consideration this point at the very beginning. I want to install a thermal power plant at this location. So I should see that whether the abundant quantity of the coal is available for me. Coal mines are very nearer from the plant. So that I have to look into whether the supply would be continuously available for the successful operation of the plant, whether it will be available at the cheaper rate for the thermal power plant, availability of the suitable site for the water power generation, for the hydroelectric power generation, whether sufficient head would be available for the water once I make a site suitable for the power generation or once I take a decision for the hydropower plant. So these parameters should be taken into consideration. The second is nothing but the cost of transmitting the energy. Now it is not only the cost of generation that is a major factor in the total cost of electricity, but the cost of transmission is also very important, isn't it? It forms a major contribution for the total cost of electricity. The cost of transmission. The cost of transmission, it means that the location where you are generating the electricity and the place or the location where you are going to consume that electricity. It means that the power generation site and the load center. So they should not be far away from each other. If they are far away from each other, then cost of the transmission lines, the installation of the transmission lines, that comes into picture. The different geographical or the topographical locations would be there where the installation of the transmission line would be a very difficult task. It would be a very tough task, isn't it? So you need to take all those components which are required for the installation to the site where you need to install that transmission tower and the transmission lines. So many factors would be there into the consideration. As far as the hydroelectric power plant is concerned, the hydroelectric power plants are located far away from the load center, isn't it? So normally for the hydro power plants, the cost of transmission is higher. Where the gas turbine power plant or say the diesel power plant or steam power, thermal power plant, they are located very nearer to the load center, the place where the electricity is going to be consumed and the place where the electricity is going to be generated. So they are not at a very longer distances, isn't it? So distance between the load center and the generation center is very less. So that's why probably the cost of transmission is less for the thermal power plant as well as the diesel power plant, isn't it? Then the cost of the fuel transportation. So definitely as far as the coal is concerned or the oil, that is the diesel is concerned. So for these two plants or say for that of the gas turbine power plant as well, the cost of fuel transportation need to be taken into consideration, isn't it? The cost of fuel uploading, cost of transportation, then cost of say downloading it at the consumption center. So all these are nothing but the cost of the fuel transportation. You need to ensure that the appropriate transportation facilities are available with you as well when you are making a particular selection for the type of the power plant. Cost of foundation and the land required. So that is really a big concern or the major concern as far as the, we can say, the hydroelectric power plant is concerned. It cannot be installed anywhere. You need to see an appropriate site, and then based upon your study, based upon your report, you may recommend, yes, this site is suitable for the hydropower plant. And normally the cost of foundation, cost of installation of the dam, so that is very high. So cost of foundation for the hydroelectric plant is very high. Why? Because the size is large for a dam, and the time which is required for the construction of the dam, so that may be very large, 10 years, 15 years, 20 years. I think some of the projects that run over a period of 20 years, isn't it? So over a period of this 20 years, we know that the cost of the raw materials which are required for the construction of that dam, so that will definitely go on increasing. So longer being the time for the construction, so larger being the cost of construction as well. So cost of foundation or the construction is normally very high as far as the hydro plant are concerned. Availability of the adequate supply of the cooling water. So just now we have discussed in reference with the previous slide, the last point that was mentioned in the previous slide. The consideration of the cooling water is very important for the thermal power plant as well as the, what you can say, the nuclear power plant, because both generate that steam, and steam is then admitted into the turbine. So water is required for the generation of the steam, water is required for the condensation of the steam. You need an abundant quantity of the water there. Then the type of the load to be taken by the plant. Now this type of the load, it means that whatever the 4 or 5 different types of the conventional power plant that we listed in the earlier slide, so they are normally classified in the 2 different headings. So one of the criteria for the classification. So that criteria is nothing but whether the plant under the consideration is the base load plant, and second is nothing but the peak load plant. So these are the normally the 2 different types of the plants: base load plant and peak load plant. So peak load plants are supposed to be the plants which are used to take the peak load, the maximum load, because this value of the peak load or the maximum load is likely to occur for a very short duration of the time of the operation, isn't it? Where the base load plant, the load for the base load plant more or less remains the same throughout their operation. So normally we can say the thermal power plant is nothing but the base load power plant, nuclear power plant is the base load power plant, diesel is called the peak load power plant, hydroelectric power plant also the peak load, and gas turbine power plant, that can be also called to be the peak load type of the power plant, because there may be certain occurrences during which your requirement or the demand for electricity is very high. For example, we can say that just in the last week, okay, the inauguration of the temple that was taking place in Ayodhya, so it was being telecasted on the television, and according to one report, the 16 crore Indian people have watched the live telecast of that particular ceremony. Or suppose you are having say the cricket World Cup final match, so it will be seen across the globe. If the India is there in final, so we can definitely say that almost every Indian would be say having their television on throughout the day to look at that final match. So it is during a particular occasion, the requirement or the demand for the electricity reaches to the peak, reaches to the maximum level, isn't it? And this phenomenon is not there throughout the day, or say on every day we can say, isn't it? So such peak requirements for some shorter duration has to be satisfied by some types of the power plants. So those are nothing but the diesel power plants, hydroelectric power plants, and the gas turbine power plants. Okay. The reliability in operation. So you need to take into consideration the reliability in operation. So reliability in operation would be essentially determined, or it will be say decided by how simpler or how complex is the entire setup for the power plant. Larger being the number of components in the operation of the power plant, so complex being the operation, and lesser being the reliability, isn't it? So that way we can say the hydroelectric power plant is the most reliable one. It just needs the dam and the your hydraulic turbine. That's it. You don't need any boiler. You don't need any steam turbine. You don't need any condenser. You don't need any pump. You don't need any cooling tower. You don't need any other auxiliaries, isn't it? So highly reliable. We can say the hydropower plant, provided the abundant quantity of the water is available. Otherwise, if the water is not there, so we cannot say it is a reliable one as well, isn't it? So you need to take into the, what you can say, different parameters to adjust, to take a decision that whether this plant is reliable one or not. Then the life of the plant. Now, as we are say making a huge investment in the installation and the operation of the plant, so life of the plant should also be taken into consideration. So one will not make a very huge investment for a very short duration of that power plant, isn't it? And normally we can see the diesel power plant are the ones which are having very shorter life. So due to this possible reason, and another say the cost of the fuel, we normally see that the very large capacity diesel power plants are not used worldwide. We will not see a diesel power plant which is of the capacity of 500 megawatt or 1000 megawatt. No, it may be say 500 kilowatt or like that. But whereas if we see the thermal power plant, 250 megawatt, 500 megawatt, hydroelectric power plant, 500 megawatt, nuclear power plant maybe 1000 to 1000 megawatt, isn't it? So the life of the diesel power plant is the least one, minimum one. Then you can have the thermal power plant which may run for the 30-40 years at the most, we can say. Okay, for most of the time after 20 years, the efficiency of that thermal power plant say falls drastically, isn't it? So that is what the life of the plant is there. And as far as the hydroelectric power plants are concerned, so definitely our intuition will tell us that the life of the hydroelectric power plant is the highest one, maybe hundreds of the years, 100, 150, 200 years. We can see many dams which were said built some 100 years ago across the world as well. Okay, so they are been still in operation, isn't it? So these 6, 7, 8 number of the parameters or the points we should take into consideration for selecting the type of generation, and then you can select the proper type of the generation for your requirement to satisfy your demand of the electricity. Okay. Now, whatever the discussion that we had till now, most of the time the discussion was revolving around the 2 points or the 2 costs. One is nothing but the fixed cost, and another is nothing but the operating or the variable cost, isn't it? So the addition of these two, fixed cost plus the operating cost, is nothing but the total cost of the power plant. So one diagram, one curve is shown there. So you draw this curve on your notebook as well and give the title there, variation of fixed and operating cost versus the investment or efficiency. So draw this simple graph. On x-axis, the parameter that we are going to represent is nothing but the investment which is required in the power plant, or say how efficient is the power plant. On the y-axis, the different types of the annual costs are taken into consideration. The 3 costs are mentioned in their bracket on the y-axis. CF, that is the fixed cost, CO operating cost, and CT, that is nothing but the total cost. So draw this diagram, draw this curve, and then we can make a few comments on the variations which can be seen on x against the y-axis. So three graphs can be seen here, three lines or the curves can be seen on this diagram. Graph 1. So graph 1 is applicable there for the fixed cost CF. Then graph 2, which is say in the decreasing fashion as we move toward the positive x-axis. So graph 2 is there for the operating cost CO. And at the topmost, a slightly saucer shape, we can see that a bend that we are having slightly there. So that is nothing but the graph number 3, which shows the variation for the total cost. Now, if we observe these graphs one by one carefully, the graph number 1, so which starts from the origin of this arrangement itself, and it follows the straight line path. Okay, graph number 1, the variation of the fixed cost is nothing but simply a straight line which originates from the origin, which starts from the origin. So it means that the fixed cost of the plant that increases with the efficiency, isn't it? It means that properly polished components, highly machined components or the machines are required to get the high efficiency. So higher being the efficiency, so definitely the costlier will be the equipment, isn't it? Costly the boiler, more efficient it would be. Costly the turbine, it would be the more efficient one, isn't it? Because it will be machined to that much of accuracy so that the required output can be obtained. And if the cost of that turbine, cost of that boiler being high, it means that it is nothing but the cost of investment. Okay, you are installing that boiler, you are installing that turbine in the thermal power plant, isn't it? So that is directly proportional. So cost, fixed cost, and the efficiency, they are directly proportional. So larger being the efficiency, so you have to pay more for that one. So hence the fixed cost continuously increases with the efficiency. Or if it is seen there onto the left, say bottom left side here, suppose here, okay, where somewhere here. So cost of investment is very less, efficiency is very less. Okay, suppose you are having 10% efficiency, 20%, 30%, 40, 50, 80, and suppose 100% efficiency. So for say 10% efficiency, so definitely whatever the equipment that you would be using, so that will be available at the cheaper rate, isn't it? So investment cost would be very less. Somewhere let us say the efficiency is being 50%. Okay, if you consider the efficiency being 50%, so efficiency now improved from 10% to 40%. So whatever the component that you would be using or the arrangement that you would be using, so definitely that will come at some higher prices, increased prices. So your cost of the investment will increase. So that way the fixed cost is directly proportional to the efficiency of the plant. Okay, I hope the variation of the graph number 1 is very easy to understand. Graph number 2, the operating cost. So it is seen that lesser being the efficiency of your equipment, higher will be the operating cost. One analogy that we can say use, if you are having say your internal combustion engine which is very less efficient, so definitely the operating cost, it means that the cost of the fuel, cost of the petrol or the diesel which is required for the operation of that engine would be very high. If the engine is having very good efficiency, high efficiency, so the amount of the fuel that is required for the operation of that high efficient engine So that will be very less, amount of fuel required will be less. So the cost of the fuel will be less. Or in other words, we can say the operating cost or the running cost of that engine would be less. So that is what it can be highlighted or it can be pointed out from the variation for the graph 2, which is applicable for the operating cost. Okay, so smaller being the efficiency, so cost of operation being very high, fuel cost is very high. And as you say, increase the efficiency, as you increase the efficiency, so definitely the consumption of the fuel will reduce. Then a boiler which is 80% efficient will consume less coal as compared to the boiler which is only 50% efficient. So that is as simple as it. A diesel engine which is 50% having the efficiency of 50% will consume less diesel as compared to the engine which is having the thermal efficiency of 30%. Isn't it? So these are inversely proportional. If the efficiency increases for the particular setup, so definitely the operating cost will be reduced. Is that fine? And number 3 is nothing but the total cost. So total cost is nothing but the addition of the fixed cost and the operating cost. So it will be seen initially that with some random value of the efficiency, say 10% efficiency that you are having, isn't it? So as the efficiency initially increases, the total cost will decrease. The total cost is going to decrease. But after a certain value of the efficiency, even though it has been say increased, but the total cost may not be less, isn't it? Because the operating cost would be the higher, the cost would be the higher, where the operating cost would be the lower one. But some point would arise where your total cost would be the least one and it would be having some value of the efficiency. And if you are say likely to operate your plant above this value of the efficiency, then possibly your total cost will increase. So that is not desirable. If the total cost increases, it means that the cost of the selling will also increase. So the consumer may not prefer to purchase the electricity from that particular agency, isn't it? So you need to maintain a proper balance between the efficiency, operating, and the fixed cost in such a way that your total cost of generation will be the minimum one. It is the least one. So that's why in one of the earlier slides we have seen that the most thermally efficient plant is not the most economical one, isn't it? You are having suppose the two plants. Let us say one plant is here which operates at the efficiency of say 30%. Okay, one operates at the efficiency of 30%. So this will be the total cost somewhere here, isn't it? It will be some of the total. But suppose you are having another plant B whose efficiency is 80%. Whose efficiency is 80%. So the cost of operation of that 80% efficient plant would be definitely higher as compared to the plant which is having the efficiency of 40%. Okay, so the most thermally efficient plant did not to be necessarily an economic one. Okay, so the appropriate balance must be maintained between these parameters. So that is what the meaning or the description of the variation of this annual cost with respect to the investment or the efficiency. I hope that you can write down the description or the variations of these parameters, these different costs in your own words. Okay. So that is what the one of the point that was say under the discussion as far as the today's lecture was concerned. And we are now about to start with the next point for our discussion. The next topic for the discussion. So that is nothing but the fluctuating load on the power plants. Write down this title in your notebook also. Write down this heading. Fluctuating loads on power plants. And let us try to understand say what are the significance or the justifications for the two paragraphs which are given here. So let us look at the first line. The load required by the consumer does not remain constant with respect to the time. The time may be either taken into consideration on hourly basis, daily basis, or monthly basis. And this load fluctuates according to his requirements. So this particular line that gives an insight, the pattern or the trend which is followed by a consumer when he or she consumes the electricity. It means that suppose as far as on the daily basis it is concerned. So whatever the number of units that I have used yesterday, not necessarily the same number of units I have used today, not necessarily the same number of units will be used tomorrow. It means that on each day, the requirement of the consumer may be different. Okay, yesterday, say I was operating my washing machine, electrical geyser. I operated with the air conditioner for some 5, 6, 7 number of the hours. Not necessarily that today also I will operate all those equipments for the same duration of the time. I may be say using only fan, or say I may be using electrical iron only today. Tomorrow, all the equipments were used simultaneously. I am using I am say keeping my television on. I am using the electrical iron. I am using my microwave oven. I am using refrigerator, air conditioner, washing machine. So all these are being say used. So it means that the pattern or the trend of this consumption need not be necessarily the same throughout the period under the concentration, isn't it? My variation of the energy consumption also changes hour to hour. It means that suppose you are say, waking up early in the morning, say 6 o'clock, and weather is cloudy and not ample sunshine is available. So when you wake up, you will definitely turn your tube lights or the bulb on in your room. It will be say running there for some hour, so up to 7:15 a.m. And once ample sunshine is available, you will make that tube light or the bulb off. Then possibly you need to go to wash, so you will start your electrical geyser. Once it is done, you will put off your electrical geyser for once the things are been done, and possibly you will use the electrical iron for some 15-20 minutes, and before leaving for your work and getting ready, you will start your fan so that you can feel comfortable. It means that your requirement are changing from hour to hour basis as well. And once you leave your home, so you are not say having any electricity consumption. As that matter, the fan is off, electricity, your electrical geyser is off, then your iron is also off, television is off. So all these electrical equipments are there in off condition. And once you return in the evening, so maybe all the electrical equipments, all the fans, tube light that you're say, starting radio, television, such kinds of the electrical appliances that you will be operating. So the line number 1 that justifies that your requirement or the pattern by which you consume the energy did not necessarily remain the same in a day. That's why in our electricity bill as well, monthly bill as well, if you see the history for some 8 to 12 months, you'll see that in every month you are having the different units that you consume. And specifically in the month of March, April, and May, which are nothing but say the summer season, you will see that your units are suddenly shooting up. And if that is there in the month of say October, November, December, it is a colder one. So your fans and your fans and air conditioner are not operating for that many number of hours. You will definitely see that there is a fall or there is a drop in the number of units that you have consumed, isn't it? So that is one of the very best example that we can make a comment that the load which is consumed by the consumer did not necessarily remain the constant, and it fluctuates all the time depending upon his or her requirements, isn't it? So that is what the meaning for the line number 1 is there, or paragraph 1. The second, the cost of generation that depends upon the first cost of the equipment which can be reduced by the simplified control and eliminating various auxiliaries and regulating devices. It means that you need to keep your plant as simple as possible. Larger number of components are involved, the complex being the plant, and the regulation and the controlling of that plant becomes somewhat a complex task, a difficult task, isn't it? So that to overcome these fluctuating loads, you need to make the different arrangements, isn't it? And the diagram which is shown here, that actually shows the pattern in which the or these are nothing but the different steps, which essentially highlights how the electricity flows from the plant where it is generated till it reaches the end consumer. So at the top it is shown that it is one type of the power plant, a generating station. Then primary substations, we can say that it is nothing but the primary distribution center, we will say. Okay, some substations are there. From substation, then through the feeders, different number of the feeders, the electricity is then transmitted or distributed to the transformers, and then these transformers are connected to the different consumers, isn't it? So on the left hand side it is shown there, distribution transformer. In a particular area you will find out a distribution transformer, and that supplies the, say, the power, or the distribute the power to some 100 200 different number of the customers. So likewise the three different consumers are shown here, which are, say, connected to this transformer. So it may be, say, residential consumers, isn't it? The others may be but you can see the commercial one and the industrial one as well. So they need their own distribution transformer. Okay, a big installation, big company, they need to have their own transformers. So that transformer will supply the power only to that consumer only, and not the set of consumers, as that is seen there in the leftmost arrangement. This transformer distribute the energy to the three different consumers: consumer A, consumer B, consumer C, isn't it? So likewise here, this transformer, it is shown here, it supplies energy to only one installation, only one consumer. So that consumer is having their own transformer, isn't it? So that is nothing but the flow of the electricity from the power generation station till it reaches the end consumer, end user. Now let us start with the terminology now, which is applicable for the fluctuating loads on the power plants. Now henceforth our topic would be to understand what different terms which are important as far as the fluctuating loads on the power plants are concerned, and how these terms can be defined. Okay, so just write down the title of this one, this term, load curve. We'll define this load curve, and then we'll possibly stop for the today's lecture. Okay, just write down the load curve, the definition of the load curve. The definition of the load curve can be seen there, written in the red color. What is it stated? A curve showing the load demand or load variations of consumer with respect to the time is known as load curve. So it is nothing but the way or the pattern by which the consumer consumes the electricity for a time under, or the time interval taken under the consideration. For example, in this arrangement, the diagram which is shown in the bottom left corner, the duration that is taken into consideration is somewhere, say, the 12 a.m. to 12 p.m. That is 12 to 12. Isn't it? 24 hours. From 12 midnight to 12 noon, and from 12 noon to the 12 midnight. Like that. And it is seen that on the y-axis, it is nothing but the kilowatt. So that is nothing but the load which is consumed by the consumer, the load which is used by the consumer. The different electrical appliances which are operating in the house of that consumer, a residential consumer. So if this load is taken into consideration, so that is nothing but the load of that consumer. So somewhere it will be having some minimum value, so minimum value of the load, and somewhere it is the maximum value of the load. It means that most of the electrical appliances for that consumer are in operating condition. He is using that one. They are put in the off condition. They are operating. Okay. So the variation of this load has been say plotted over a time interval under the consideration here, that is a 24 hours. So this is nothing but a hourly load curve. Okay, from 12 to 3 a.m., 3 to 6 a.m., 6 to 9 a.m. So definitely some interval is taken into consideration. Okay, and the variation of all these load with respect to the time is known as the load curve. So write down this definition. The curve showing the load demand or variations of consumer with respect to the time is known as load curve. Now the more discussion onto the load curve or the characteristics of the load curve and other terminology related to the fluctuating loads on the power plants, so that we'll discuss in the coming lecture. Okay, so keep your notebooks and pens ready in the next lecture as well, and we'll write down their definitions one by one, so that it will be possible for us to then make a smooth transition for solving the different numericals for the fluctuating loads on the power plants. So I hope that the time is coming to end. We are almost toward the end of the lecture. It is less than a minute or two that is remaining. So we'll stop here for the today's lecture. I hope the things that we have explained today are not that much difficult to understand. Please go through this video repeatedly if you couldn't understand, and if anything which has to be say the stressed more or more importance should be given, so please let me know, so that I can again explain those things in some better fashion, better manner. Okay. So thank you very much for the today's lecture, your kind attention, and we'll take on to the remaining parts for the terminology the coming session. Okay, which is there on Wednesday morning. Okay, 9 to the 10:30. Okay. So thank you very much for your kind attention.